The Atlantic Ocean holds a secret deep within its waters. Scientists have made a startling discovery. The ocean has a long memory. This isn't about sunken ships or ancient myths. The Atlantic Ocean can remember climate conditions for an astonishingly long time, up to 20 years. This discovery has sent ripples of excitement through the scientific community. It changes our understanding of how oceans influence the climate of our planet. The Atlantic Ocean plays a crucial role in shaping global climate patterns. Its ability to remember past climate conditions has profound implications. Imagine the ocean as a giant memory bank, storing information about past temperatures and weather events. This memory influences weather patterns and long-term climate trends. The discovery of this long memory is a game-changer for climate science. Understanding the ocean's memory is essential for predicting future climate change. It could help us anticipate extreme weather events, sea level rise, and other impacts of a warming world. The Atlantic's memory is a powerful reminder of the interconnectedness of our planet's systems and the lasting legacy of climate change. How can an ocean remember? The Atlantic's memory isn't about conscious thought, of course, it's about physics and the remarkable properties of water. The ocean acts like a massive solar panel, absorbing and storing vast amounts of heat from the sun. This heat isn't just sitting there passively, it's constantly on the move. Vast, slow-moving currents circulate this heat around the globe. Imagine these currents as conveyor belts carrying warm water from the tropics towards the poles and cold water from the poles back towards the equator. These currents interact with the atmosphere, influencing weather patterns and climate conditions in different regions. The speed of these currents is key. The slow, churning movement means that temperature variations can persist for decades. Think about a time when the ocean experienced a particularly warm year. Those warmer than average temperatures carried by the currents can still be influencing weather patterns decades later. This is the essence of the Atlantic's long memory. It's a testament to the ocean's immense power and its profound influence on our planet's climate system. The discovery of the Atlantic's long memory has profound implications for climate predictions. Imagine trying to predict the weather without knowing anything about the past few weeks of sunshine, rain, and wind. That's essentially what climate models have been doing without a full understanding of the ocean's memory. Current climate models, while sophisticated, often rely on shorter-term ocean memory data. The discovery of the Atlantic's 20-year memory necessitates a significant recalibration. Incorporating this long-term memory into climate models is crucial for making more accurate and reliable climate projections. This improved accuracy is vital for policymakers and communities preparing for the impacts of climate change. Imagine being able to anticipate severe droughts or intense hurricanes years in advance, giving time to prepare and adapt. The Atlantic's memory offers a powerful new tool for understanding and predicting our planet's future climate. The Atlantic Ocean's impressive memory is a result of two key factors: its circulation patterns and its heat capacity. We've already touched on the role of ocean currents, those massive conveyor belts redistributing heat around the globe, but the ocean's heat capacity is equally important. Water has an incredible ability to absorb and store heat. In fact, the ocean absorbs a staggering amount of the excess heat trapped by greenhouse gases in the atmosphere. This makes the ocean a crucial buffer against rapid climate change, but it also means that the ocean is slow to release this stored heat. Imagine heating a pot of water on a stove. It takes time for the water to warm up, and it takes time for it to cool down again. The same principle applies to the ocean, but on a much grander scale. The ocean's vast size and its high heat capacity mean that it can hold on to heat for decades, influencing climate patterns long after the initial warming event. This combination of slow-moving currents and immense heat capacity gives the Atlantic its remarkable long-term memory. It's a complex and fascinating interplay of physics and chemistry that has profound implications for our planet's climate.